What's going on, people? Today we're talking about Alzheimer's disease. What is Alzheimer's disease? Alzheimer's disease is a disease in which brain cell connections in the cells themselves eventually degenerate and die, destroying memory and other important mental functions.
Alzheimer's disease requires a medical diagnosis to identify. Memory loss and confusion are the main symptoms, but other symptoms include mood swings, mental decline, difficulty thinking and understanding, disorientation, forgetfulness, difficulty concentrating, inability to create new memories, hallucinations, and the decreased capacity for motor functions.
Cells generally communicate to each other like two people talking. They're free to communicate as long as there's no barrier in between them. But in the case of Alzheimer's, these plaques act as a brick wall. Now think about a brick wall being built in between these two people. They can't communicate as easily as if there weren't. After initial symptoms, victims have an approximate 3 to 20 year lifespan, as there is no cure. According to the Mayo Clinic, over 3 million cases of Alzheimer's were found annually in the US. Also, according to the Mayo Clinic, Alzheimer's is found in 10% of people over 65 and 50% of people over the age of 85.
On Valentine's Day of 2017, Merck announced that it is stopping clinical trials of a pill it was developing to treat Alzheimer's known as Verubicestat. Other failed drugs in the past decade include an antibody drug made by Eli Lilly, medicine from Pfizer, Johnson & Johnson, and Elan Pharmaceuticals, and a new drug called aducanumab from Biogen is expected in 2019. Currently, there is no cure for Alzheimer's disease, but drug and non-drug treatments may help with both cognitive and behavioral symptoms. Alzheimer's is caused by integral membrane protein APP, or amyloid precursor protein, changes in the normal versus diseased state. In the normal state, APP is initially cleaved by alpha secretase to generate what's known as SAPP and a C83 carboxyl terminal fragment. The presence of SAPP is associated with normal synaptic signaling and helps and results in synaptic plasticity, learning and memory, emotional behaviors, and neuronal survival.
In the disease state, APP is cleaved sequentially by beta secretase and gamma secretase to release an extracellular fragment that results in the creation of intracellular plaques. Plaques, abnormal clusters of proteins, fragments, build in the synapse and interrupt the transmission of neurotransmitters, making the creation of memories nearly impossible. The damage initially appears to take place in the hippocampus, the part of the brain essential in forming memories. As more neurons die, the additional parts of the brain are affected and begin to shrink. By the final stage of Alzheimer's, damage is widespread and brain tissue has shrunk significantly.